Okay, the floor is yours.
So the agenda of today's discussion is we first look at the overview of the proposed collaborative environment architecture. Then we will have an overview of the xText-based blended modeling. Basically, it is important to get the basics of the xText-based blended modeling because it is required in the collaborative environment. Then we will discuss the implementation possibilities in line with the proposed collaborative environment architecture. Then we will have a demo. And finally, we will discuss the few important xText features in the context of collaborative environment. And we will also discuss how support for MPS can be incorporated in xText-based collaborative environment. So this is the high-level architecture of collaborative environment as proposed by Wino. So here you can see different clients like textual editor clients and graphical editor clients can connect to the Bumble collaborative engine. Yeah, and then the real-time collaboration will be achieved. We will discuss how. But in this discussion, we will mostly focus on the xText-based collaborative environment. We will not consider the MPS-based textual editor, for instance. But of course, we will discuss few possibility how MPS port can be incorporated in the current architecture. So basically, this is the very abstract architecture of xText. There are the textual model, those are referred as the parsing tree node models, and there are AST. Once the textual model after parsing, it will have an AST, and when we will have some changes in AST, then the serialization is performed and the AST converted back to the textual model. So basically in blended modeling, the AST and both node model and AST plays an important role. So this is the architecture of the blended market architecture based on the xText. Here you can see the xText-based textual editor are developed using the xText built-in features. Here there is a parsing tree and then associated AST. On the other hand, there is a graphical editor and of course there is an AST. So basically we are here to perform, yes. So here we perform the synchronization between the ASTs. These are the high order transformations that the MDU is currently working. And in this way, we will achieve the blended modeling or runtime synchronization between the graphical and textual syntaxes. So if we look again at the architecture, there are different possibilities available. For example, first implementation possibility, exactly if we can say. So here, if you can see that for xText part, let's say the client 1 has a graphical editor, client 2 is using the textual editor, client 3 is using the graphical editor, and client 4 is using the textual editor. So, and for synchronization, they all linked with the collaborative engine. But there are two issues in this implementation. First one is complexity. There is a need to perform the dual synchronization, one for blended modeling and second for the collaboration itself. For example, if client 1 is connected here and client 2 is connected here, so there it is required to perform the synchronization between client 1 and client 2 as well, and same is the case for client 3 and client 4. And apart from the blended modeling synchronization, the management of hidden regions, these are the important aspects, as uh, most of the blended modeling is based on the hidden regions. I mean, as far as I know, at least it is true for HCL case. So the implementation of this architecture is, I'm not saying it's not possible, but it will be a problematic and may be impractical in real industrial environment. So this is the another implementation possibility. Here you can see that each client has both graphical editor and textual editor. Similarly, client 2 has a graphical editor and textual editor, and there is a synchronization between graphical editor and textual editor. And before going for the collaboration, the synchronization for blended modeling will be performed, and there there is a need to only perform the real-time collaboration between the clients. So this is the more practical architecture as per my understanding. So, and another benefit of this architecture is the blended modeling synchronizations could be treated separately before collaboration. So we will discuss it in the subsequent slide. So point is, if we go for this implementation, so what should be the implementation architecture? I mean, there are several tools available, and you already performed the detailed analysis. But what I can highlight or discuss is why xText, we use xText for collaborative environment, in fact, including MPS. So these are the few reasons that we should use the xText-based collaborative environment in Bumble. First of all, we have a more control over blended models, as both Node and ASTs are accessible. So first point is the tool-specific conversions of models are not required during merge, as we already have the AST, xText ASC accessible. Otherwise, we have to convert into a string and stuff like that if we use another tool. Then second point is it is easy to achieve the real-time collaboration, rule-based merger, because it supports the client-server architecture, and there are other features we will see in the demo. And it's also extendable for future expansion. And one feature in this context is it provides the built-in feature to ensure the correctness of collaborations. And the other thing is that it has a built-in support for advanced collaborative view or collaborative inventory maybe. So it provides the built-in feature for models highlighting and visualization after merger or before merger, or even we can implement the rules at each client side separately. Then the biggest plus is that it provides the support for web-based client-server architecture. So implementations of sessions and other operations are easy to achieve. We will see also in a demo. It's not fully covered, but at least I will show how the web-based client-server architecture of xText works. And another important point is its support persistence, which is an important element of the collaborative engine. So due to these features, it is highly suitable to use the xText architecture. So if we map the architecture here again in this context, so here you can see that the server is collected with the central workspace, so we can use the different workspace as well. And then there is a session to each client. And this is important that we have the synchronization of blended modeling. And here these are treated separately. And once there is a synchronization between graphical and textual editors, we just need to put the collaboration or merger between textual editor. And in this way, the client, the blended modeling synchronization are treated separately. Means it provides a high level of separation of concern, and we just need to merge the textual editor or textual stuff, and as according to the architecture of xText, so ASTs are available and high order synchronizations will done the job for blended modeling.
Can I ask you a question?
Yes, yes, sure.
Because you mean by collaborative modeling also immediate synchronization, that you include that in this picture, so that the two clients can work at the same time on the same model? Is that what you also imply with this, or is this more a
yes,
Git or yes?
I mean, the central workspace basically refers to it. It can be different clients connected to the different. If I talk about the technical terms, then different grammars, xText grammars, or the basics. So I mean, the clients, different clients, it's just a depiction what can be achieved in this context. And of course, here you can see that I have just mentioned few server features like session management, merge policies, highlighting and visualization. Of course, it's also the part of the client, and then logging is also available, and persistence.
Okay.
So I think now let's start the demo. So here we just use a simple grammar. I mean, I have just demonstrated through a simple grammar, and why my system is not, it's getting slow. So this is just a simple grammar. I mean, if we look at the runtime, so there is a planning, and a task can be defined and the person associated with the task. So this is a simple grammar. But point is, here we use the let's say there are different clients available like merge DSL, merge DSL3. So here we are going to merge merger and merger 3. Basically these two clients, we are going to merge these two clients here, and we will merge it in the server. But for demonstration, we show the merger here in the merger for DSL. So before we going into the merger, there are a few rules for merger. First one is all the persons should be sorted in the ascending order. So this is the first merger rule. All persons should be sorted in the ascending order. And then second rule is that if there is a duplicate person here, so these should be renamed randomly. And finally, if there is a duplicate person, the renamed person should be displayed in a red color. So these are the very basic rules that we have, that I have implemented it here. So let's so here there are two John. So let's so far here it's so let's see. So here you can see now John is renamed as a John 4 and displayed in a rest color, and all the persons are sorted in the ascending order. So this is just an example. So if I have to save the time, I have a bit big instances here. So let's check. So now we have two a bit bigger models here. So let's save it. So here you can see that the LS, rename the LS and so on, and sort all the persons in an ascending order. And this merger fold, I mean, DSL is also available as a tree editor, or you can say it AST basically. So basically this AST is important for the blended modeling. Here all the persons are available. So this is just the demonstration. Now let's see it in the context of, so xText provides recently, in fact, included the new feature that supports the web-based client server architecture. Here I'm going to launch the server. Can you see my screen? I mean,
Yes.
yes. So, so server is now started, and we can now access the web clients here. So this editor is available here, and I think I just, let's start. So editor is available, and yeah, and here you can see that the duplicate names, it's already there is a validator check that I have talked about in my presentation earlier. So this is how it works, and in fact, I'm not implemented the very good sessions here, but point is, it's just for demonstrations that yes. So this is another client. Let's replicate the client here.
How do you define in your syntax in xText which what is used for comparing the identity? Because this is in this example it's clear, but how do is there a certain way of annotating that, or how do we do that?
You are talking about the comparison.
Yeah, but you're stating here that there are two elements of the same name, and that's
yes, it's in the validator.
It's so, but it's a validator on the AST of xText.
Yes, there are so many projects. I mean, here when we talk about the web, in case of the desktop application, here are the validators that we can implement here, the validators and the validator.java. So these are the just simple code I have just commented in the client side. And similar is the case with the web-based, but of course its architecture is different. I mean, there are so many additional things we can define the server and stuff like that. So the point is we need here I just use the basic feature for demonstration. Of course, these sessions need to be maintained in a better way, and xText supports it. We will see in the presentation. So there are different things. I think if you want the more detailed discussion, we can discuss it even with the thing, but it's for demonstration. I mean,
I think that Wim was aiming at, I mean, understanding how elements are uniquely identified in xText, right?
Yes,
how do you?
Because that's both for the merge and for the validation the same.
So they're used in the same. Yeah.
Okay.
And that should be defined in a way that I can easily
basically
find it for a certain syntax or a modeling language.
Yes, I mean here if you are talking about, I already demonstrated that there are two trees basically in xText. One is a node model and other is an AST.
Yes.
So basically, we are working on a node model here, and we fetch the I hard coded the exact path here, but we can use the dynamic path here to fetch the values from the other, and then there are yes.
But even in a node model, or you have to define which elements are identifying for a certain node in a certain context. So that's not derivable from an xText specification.
But this is a semantic validation rule, I think, implemented in Java, that where you define what you consider to be a duplicate or not.
But you implement it in a way in Java for a certain language, which can both be used for guarantee uniqueness and for the merging, because the merging needs also to recognize when two elements are the same.
Yes,
yeah,
of
but that's
course.
yes.
But that is what I try to get to. But you do not have to implement a merger for a new language again. You derive that from the language specifications or not? But that's just a question.
Yes, I mean, we have to, this merge will work. Of course, each language has its own semantics. Here we are dealing with the persons. So, of course, there will be few changes while doing the merge, but for the same language, it will work for all elements, because here, if I can show you that, we are basically getting all the elements from the, you can say, from the node model and then merge it, and it's a simple case. I mean, just for demonstration, I have just picked all the elements, converted them into the Java string, and then just applied the sorting. Okay. And in case of duplication, here I have used the formatter to display the red color. So that's it.
So I can mention in Artist what, because in xText every element has a URI, and by default that is based on the qualified name, but you can customize that any way you like. So you have different rules for how you compute the URI, and we are using the URI in Artist for knowing if two elements are the same or not when merging. Okay. Semantic validation is a different thing. Then the language may allow duplicates or may not allow duplicates, and there may be different criteria for what you consider a duplicate. So that is more like some Java code that is specific for a particular language that you implement.
Okay.
Yeah, exactly. So I think this was the answer that Wim was looking for. So yes. Let's say the merger here is language specific. So you do not derive it automatically from the language, but it's ad hoc defined. Then I think that, I mean, this is said some, I mean, it's how do you call it? Experimenting ideas. So, and then if we find the way we want to have this, how we want to have this, then we may go over to automating their, I mean, the derivation from a specific language. But I foresee, at least as said, for semantic comparison, merging, you will always need some sort of input from which is language specific. So it's probably even the end user specific, you know, because two persons may use the language in different ways.
Clear.
Okay, so can we move forward? So this is just a simple demo, I mean, for web-based ports in the xText architecture. And if we move back to the presentation here, we can see the detailed or more technical architecture of the collaborative engine. Here we can see that there is a different light consistency checker that we have seen in the demo, and then server and client based different sessions, client sessions, And there are so many stuff, but if we look at the, this is basically the official web page of the web editor supports in the xText. And here you can see there are 3 JavaScript text editor libraries can be linked with the xText, and by default here it's using ACE. So I have just developed the demo in the ACE. These are the features that we are looking in our collaborative environment: content assist, validation, syntax highlighting, and all available here. And similarly, formatting, code generators, even after merging the code can also be generating. And persistence is also there. And there are 2 models, stateful and stateless mode, are available here for client. And for persistence, there is no built-in mechanism, but we can manage it through the server resource handler interface. So this is the part for the xText. Now, if we look at the MPS, so point is, could we access the MPS AST here in the Bumble collaborative engine? And if so, how? So I didn't explore this in much detail, but the basic is we just provide the mapping at the meta level between MPS eCore, and it's easy to achieve this mapping. But for instance level, the only way to achieve it, as per my understanding, is the AST, because despite several differences, there is a one important similarity, and that is AST. So basically, xText utilizes ANT-LR parser for AST, and I think this is the also linked with the question of Wim, that for generic, you mean merger and other things, it is important to know in advance how parser is behaving, because if we know that, we can implement the generic implementation. I mean, we can implement some generic rules for that. So ANT-LR is based on an allsteric algorithm, and good point is that ANT-LR parser could be used in MPS for AST. The demonstration is available in the given link. So I believe it's fairly possible to support MPS using xText-based collaborative environment, but further investigation is needed. I think MPS AST could be accessed in xText environment. Maybe it is in the form of string, Java strings, not in its pure form, but it is possible. But important is if both AST, I mean MPS and xText ASTs are using the same parser, then we know how the AST will behave in the case of changes. At least up to some extent, we know how AST is going to build. So in this way, I think, but I'm not sure. I think we need to discuss it, and maybe Wim can highlight this possibility.
Yeah, I'm not completely sure what you. I know that there's an AST in MPS, and I also know that there is an AST for xText, of course, but.
The point is how we can fetch, because I initially explored it while we were working on the language level or structure level mapping between eCore and MPS, and we
So the approach that we are planning to take is that we can actually translate a structure model, which is the meta model in MPS, into a eCore model. Vice versa is very difficult, because eCore meta models have a much richer type system, but the other way around is quite trivial actually. So then you have a EMF model, which is the same as the structure model, and then it's only one technical level of synchronization, which you do not have to change, but that's the bridge between EMF and the structure. So the node models in is actually named as node models in MPS. And then, yeah, you are in the EMF ecosystem, and then you can do whatever you like. So that's our approach. But how that relates to xText, of course, you can put in xText on top of that in EMF anyhow, or transform it to another EMF meta model, which is more richer or geared to your syntax in the EMF environment, in the Eclipse environment. But I'm not getting the xText as a mean for interoperability in that area. That's not what which is difficult, because of course you can create a textual syntax that is able to render all node models in MPS.
Yes.
But I doubt whether that's useful.
Yes, this is the point. But I think maybe, but it need further investigation. Of course, it's
yeah.
So
but
one more.
this is a yes.
One comment also. I think xText is only useful if there is a textual syntax for a modeling language. And for example, in Artist, we have it for parts of the meta model, but not for everything. So I think maybe it cannot be the only solution for.
Yeah, but you can also use xText for creating a persistent way of persisting arbitrary languages, even graphical languages, or
Yes.
make it easy to merge. But that's an extra effort that you have to take.
Yeah, I mean, you can invent the syntax for everything, of course.
Yeah, something that in a way that you can persist any other model. If it's because at the end in EMF everything is just an EMF model in memory, and any EMF model can be serialized via xText.
Yeah, but in this picture, when you're saying texture editor, it may be that some parts you don't see in the texture editor. There are other parts of your modeling language that you see in other views.
Exactly.
For which there is no textual syntax defined in xText. But you can do it, but
Yes.
And also, if you want to diff and merge, and the user is used to look at the graphical editor, then you would prefer a graphical-based diff and merge, because that's the way they think, and not the textual one, because that's only a persistent format from that perspective.
Yes.
Yeah.
So I think this is from my side. Now I think you can further extend it, or maybe so, Ivan.
Yeah, I see some, of course, some touch points, and I think we need to think at some point. What we are doing from our side is, if you look at your slide 12, with COSAR, we are working on the implementation of the backbone, not of the plugins, but of the backbone of the architecture. And I think that once we have some kind of, somehow stable version of this backbone, then we can sync and we can integrate the two parts.
Yes, sure. Well, so, I mean, yes.
And that is our top priority now. So it's in the making.
Yes, basically, I think feedback from the HCL is really important in this context. Just they mention the methods, just mention few important points that, I mean, particularly related with industrial settings.
Yeah. And at some point, we need also to evaluate the performance overhead of what we are proposing, but also, the user experience of all of this machinery. At the end of the day, these editors must be used by people.
Yes,
So
sure.
we can have a perfect tool for model synchronization, but if the overall user experience is not good, then you know, you have a problem.
Yes.
Okay, I think I can stop recording now.